Good day, students. Welcome to mathgotserved.com. In this clip, we are going to be going over problem number 7 of our Unit 4 test on application of derivatives, okay? In this problem, we are going to be focusing on linearization. For problem number 7, we are to find the linearization L of x of f of x equals 1 over 1 plus tan x at a equals 0. Okay? All right. Now, let's write down the formula for linearization first, and then we'll proceed to find the linearization of this function. Linearization of a function L of x is equal to f of a plus f prime of a times x minus a. All right, so this formula is the same formula as the point slope form of the equation of a line that you learned in Algebra 1 and 2. So we have y equals y1 plus mx minus x1. All right, so it's the same thing. This is a much more advanced notation for the equation of the tangent line. It helps you get ready for the more complex topics in calculus 2 and 3. Okay, so we're going to be sticking to the more advanced notation. This is advanced, and this notation is elementary. Okay, is limited in its application. All right, so let's go ahead and do this. So if you think back to Algebra 1 and 2, if you want to write the equation of a line, you need a point and a slope. That's exactly what we need here, okay? So in this format, using this advanced notation, the point is a comma f of a, and the slope m is basically f prime of a. All right, you can see y1, x1, and then m is f prime of a. All right, so let's go ahead and find the components that we need. First, we need to find a. A is given, a is 0. That is the x coordinate of the point that we're finding the linearization of the curve at, okay? We need the y coordinate next, so we need to find f of a, which is f of 0. Since a is 0, we're going to evaluate this function at a equals 0, so we have 1 over 1 plus tan of 0. Okay, so we're going to have 1 over 1 plus tan 0 is what? Tan 0 is 0. If you remember, if you think about your tan curve, let's sketch that real quick. Your tan curve looks something like this. Sketch that again. So it's concave down, and then concave up, and then concave down. So at 0, tan of 0 is 0, or you can think about tan 0 as sine 0 over cosine 0. And we know that cosine 0 is 0, and sine 0 is 0, and cosine 0 is 1. So 0 over 1 is just 0. Okay, so we have 1 over 1 plus 0 equals 1. So that is your y coordinate. What do we need next? We need f prime of a. Okay? In order to find f prime of a, we need to do two things. First, we have to find the derivative f prime of x. All right? And then secondly, we need to evaluate the derivative at a, which is basically going to be f prime of 0. All right, so the two-step process. Now let's go ahead and start by finding the derivative. Let's rewrite the function f of x. I want to find the derivative of this function. F of x is equal to 1 plus tan x. Okay, so to find the derivative here, f prime of x is 1 over 1 plus tan x prime. So I can use the quotient rule here, but if you notice, the numerator is a constant, so I can simply express this using the reciprocal property of exponents and simply use the chain rule. So this can be written as 1 plus tan x raised to the negative 1. So I'm looking for the derivative of this composite function. All right, I don't have to use a chain rule. You could use a chain rule, but that's too much. All right, so let's find the derivative using the chain rule. The derivative of the outside function. In this case, the outer function is x to the negative 1. Its derivative is negative x to the negative 2. The inner function is 1 plus tan x, and its derivative is 0 plus secant square x. Okay? All right, so let's apply that here. Differentiate the outside, evaluated at the inside. So we have negative 1 times 1 plus tan x raised to the negative 2 times the derivative of the inner function, which is going to be 0 plus secant square x. All right, now that's f prime of x. We're done with the first part. Now we need to evaluate it at a equals 0. Okay, so we have 1, negative 1 times 1 plus tan 0. This entire thing raised to the negative 2 times drop 0 secant square of 0. Okay, all right, let's go ahead and evaluate this. We're going to have negative 1. Remember, tan of 0, we talked about that earlier, is 0. So we have 1 plus 0 is 1 raised to negative 2. Secant square 0 is secant 0 square. Okay, secant 0, this is a reciprocal trig function. It can be written as 1 over cosine 0. Now we know from the graph of the cosine curve that cosine of 0 is 1. Okay, so we have 1 over 1, which is 1, so secant of 0 is 1. So we have this times 1 square, since we're squaring secant. If you simplify this, you will have negative 1 times 1 times 1. Okay? The reciprocal of 1 is 1. When you square it, you just get 1. All right, so now we have our slope, f prime of 0 is negative 1. So we have all the components we need to write the equation of our to write the linearization. Okay, and remember, the linearization is just the equation of the tangent line. All right, so let me rewrite the formula again so that we can apply our results to this situation. So the linearization of the function is f of a. What is f of a again? F of a is 1. Okay, so we have 1 plus f prime of a, the slope, negative 1 times x minus a, which is 0. All right, let's go ahead and simplify this. This is going to be 1 minus x. So that is the linearization of the function at x equals 0. So let's go ahead and box our final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or comments or requests for calculus tutorials, feel free to include that in the comments section below this video. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.